got the other way. Well, the only difference is that the exponent is going to be a negative. Iodine 131 is a radioactive material that decays according to the function, and here it is right here. You can't see it because it kind of got lost in the table, because I brought it over as an image. Where A0 is the initial amount present, and present at time t in days. So t is time in days, so we know what the units are. And what is A of t, according to the function initial amount, and grams. T is the amount left. In grams. And it tells us that assume that a scientist has a 100 gram sample. A of 0 is going to start out at 100. So our function is going to be A equals A0, which is 100, e to the negative 0.087 times t. That's why I had to type it, because it's too hard to see unless I type the problem, and I don't want to do that. Now, what is the decay rate of iodine? Well, what's K in this instance? Negative 0.087, or what? What is a percent? .087 is, what is a percent? 8.7% per what? What's the units on time? So the decay rate is 8.7% per day. And then it says how much is left after 9 days. That means that t is 9. So that A of 9 is 100 e to the negative 0.087 times 9. And again, our handy dandy little calculator, 100. And then e to the negative 0.087 times 9. Nice thing about having pretty print that it does the exponent thing. If you don't have that and you're like my old one, then this has got to all be in parentheses. And I'm going to have 45.7 what? What's the units? Grams. See, that's why we have this up here. To remind us that T is in days and A of T is in grams. And then when will 70 grams of iodine be left? So 100 e to the negative 0.087 t equals 70. E to the negative 0.087 t equals 70 over 100, which is 7/10. So that e to the negative 0.087 t equals 0.7. And now I get to do what? Natural log both sides. So natural log of e to the negative 0.087 t equals the natural log of 0.7. Bring down the exponent, so negative 0.087 t equals, well, let's see, natural log of e equals the natural log of 0.7. Natural log of E is 1. So that T is the natural log of 0.7 divided by negative 0.087. And then you get your calculator. And it is the natural log of 0.7 divided by the opposite of 0.087, or 4.0 or 4.1. T is approximately 4.1 what? Days. Now, what does half-life mean? What's half-life mean? Find the half-life. What's half-life mean?
Half the time.
Not half the time. Half the amount. So what is the half-life of iodine? This means half the amount. Which means that A of T equals what? With 50. That's half the amount. So now we get to do this all over again with 50. So that 100 e to the negative 0.087 t equals 50. Or that e to the negative 0.087 t equals 50 divided by 100, that's 1/2. Natural log of both sides, natural log of e to the negative 0.087 t equals the natural log of 1/2. Bring down the exponent, negative 0.087 t. Natural log of e is the natural log of 1/2. Natural log of e is 1, or t is the natural log of 1/2 divided by negative 0.087. Or t is approximately well, it's 7.967. What? What's the units? Days. Or you could say 8 days, right? Because the minute you start rounding, this would be fine, 7.97. But if I start rounding, this 6 turns that into a 0, which turns a 7 into an 8. So 8 days, it's an approximation, would be about right. See, these problems could get kind of boring. The process is the same, every single one.